All right, all right, all right, all right, all right, all right. Welcome. All right, now today is 8.3 notes. All right, today we're going to focus on the letter E. Now, what is the letter E? Well, I'm going to start by making this chart. All right, we're going to kind of make a T-chart. So I'm going to call this N. We're going to go across. And down in the bottom left here, I'm going to put 1 plus 1 over n, all to the nth power. Now, our boy Euler, was an awesome mathematician, and notice something a little funky about this. All right, and it's kind of a cool concept. All right, let's say n is 10 to the first power. So n is just straight up 10. Now, if you look inside the fraction here, we have 1 plus 1 over n. So as this continues to get larger, all right, what happens to our fraction? Because if we went 10 squared, that would be 100. If we went 10 to the third, and I'm going to keep this going all the way to 10 to the fourth, 10 to the fifth. All right, so my n value is going to be increasing, 100, 1,000, so on and so forth. So think about it. If we put this in on the inside of the parentheses, this fraction 1 over 100, 1 over 1,000, 1 over 10,000 continues to get smaller and smaller. However, we're raising it to a power that gets larger and larger. So it's kind of contradicting. All right, so as this number gets smaller and smaller and smaller, this one's getting larger and larger. And a special relationship happens. So if you put this in your calculator and you go 1 plus 1 over 10, all raised to the 10th power, it gives you 2.594. All right, and then we start getting bigger. So now we go 1 over 100. So again, this fraction's getting smaller, but my exponent's getting bigger. You get 2.705. Now, this is a little weird, so put in your calculator if you don't believe me. All right, 10 to the third. So now we're going 1 over 1,000, fraction getting smaller, exponent getting larger, and you get 2.717. Now, something funny's happening here. It's not getting much larger. So what do you think is going on? All right, and then you got, if you did 10 to the fourth, you get 2.718. Again, your fraction's getting smaller. This exponent's continuing to grow. If you go 10 to the fifth, you get 2.718. All right, and this is our number right here. All right, so what Euler said is, as this gets smaller and this gets larger, your numbers actually approach this 2.718 number. So as n goes to infinity, because these numbers just get larger and larger and larger and larger, all right, f of n, this special function here, approaches 2.718. All right, and this is called Euler's number because he discovered this or invented it. I don't know. All right, and we call it the natural base. Now, today's kind of just an introduction to this variable e that exists. Kind of like pi equals 3.14, its ratio. E is a natural base that always equals 2.718. All right, and we're going to, as we move forward, we're going to use it with logs and things of that nature, and you're going to hit it pretty hard in pre-calc next year too. So today, it's kind of your first exposure to it. So that's all about the letter E. It's kind of a lengthy explanation, I know. So what are we going to do with it? All right, well, first thing we're going to do with this is simplify it. Now, when we simplify it, we're going to treat it like any other variable. Okay, we're going to treat it like it's x when applying all our exponential rules and all that stuff, good stuff. So let's say we had e to the third times e to the fourth. Again, treat it just as it's x. We have e to the seventh. Now, you could put that in your calculator. All right, and if you hit e to the seventh, it would take 2.718 raised to the seventh power, so on and so forth, and give you a decimal answer. However, I'm asking you to simplify. If I said evaluate, you would do it differently. And we'll talk about how to do it on the calculator tomorrow in class. All right, what if we had 10 e to the third over 5 e to the second? All right, so we treat the 10 and the 5 the same. 10 divided by 5 is 2. E to the third, e to the second. Well, who wins? Well, the top wins by 1. So 2e, or 2e to the first. All right, we've had 3e to the negative 4x squared. All right, and this is where a lot of us made our mistake on our quiz. We need to take this squared to both. So I get 3 squared and e to the negative 8x, because negative 4x times 2 is negative 8x. So I got 9e to the negative 8x. Not allowed to have a negative exponent, so you got to bump them downstairs. E to the 8x. All right, one more for you. The 4th root of 16 e to the 8x. All right, well, the 4th root of 16 is just 2. Now, e to the 8x to the 4th. Now, how am I going to do that? Now, treat it like it was just x to the 8th to the 4th root. How many groups of 4 do you have in there, right? We would take out x squared. Same idea here. What this says is e to the x times e to the x times e to the 8x, 8 times. All right, so we're going to treat it just like we treat this. So e to the 2x actually comes out. All right, so try to make that connection there. We treat it just like that. All right, good. Now, what's the purpose of this? We do have one more formula to add to the mix. All right, and this is, it's called the PERT formula for short, because it's the total amount equals the principal times e raised to the rate times time. Now, we use this in a special case, all right, and I'll explain in a second here. So let's say you invest $1,000. All right, you get your first job, you save yourself some money, and you're going to invest it for 5 years at 7% continuously. Okay, I spelled that right. Now, this is the key part. When compounding continuously, we use the PERT formula. All right, yesterday we talked about our interest formula, right? Now, our interest formula is just being compounded. When you're compounded continuously, that's when you use your E value. All right, so in this case, my principal is 1,000. My time is 5. And my rate is 0.07. All right, so I have A equals 1,000 times E, r raised to 0.07 times 5. All right, so in your calculator, you're going to type in 1,000, okay, E raised to parentheses 0.07 times 5. And you can do that all at once to get your solution. So that's what you're going to type in your calculator. And then your total amount should be 1,419. And that's your value there. All right, so we now have 4 equations. We'll talk about them in class tomorrow, but you need to know them all for your quiz. All right, so what do our equations look like? Let's review them real quick so they just stick in your brain. Okay, we have AE times 1 plus R to the T. That is our growth formula. We have A times 1 minus R to the T. That's our exponential decay formula. So this is when we're growing, decaying. We have our interest formula. That is simple interest. Okay, when compounded annually, yearly, once pretty much there's a time frame that I give you. And then we have one that's compounded continuously for a period of time. All right, now the toughest part, they're all easy to remember. The toughest part is deciding when to use which one. All right, and there's some keywords that go with each one that we'll talk about again more tomorrow. Okay? All right, thanks. See you in the morning.